We look into the universe and assume that what we see is what exists. Galaxies stretch across space. Light travels for billions of years. And we believe the universe is open to us. But modern cosmology tells a different story. Most of the universe is not hidden in darkness. It is already beyond our reach. Not in the future. Not someday. But right now. For a long time, humanity believed that the universe was something we could eventually understand completely. If we built better telescopes, if we waited long enough, if we gathered enough data, we assumed nothing would remain out of reach. But this assumption turns out to be false. Not because our technology is limited, but because the universe itself has limits that no technology can overcome. In cosmology, there is a concept called the cosmic horizon. It is not a physical wall. It is not a boundary made of matter. It is a limit created by time, by the speed of light, and by the expansion of space itself. Light does not travel infinitely fast. It moves at a fixed speed, and the universe has a finite age. Because of this, there is only a certain distance from which light has had enough time to reach us. Everything beyond that distance exists outside our observable reach. Not because it is hidden, but because its light has never arrived here. At the same time, space itself is expanding. Galaxies are not simply moving through space. The space between them is stretching. As a result, some regions of the universe are receding from us faster than light can travel. This does not violate physics. It is space itself that is expanding, not objects moving through space. Because of this expansion, there are galaxies whose light will never reach Earth. Not now, not in the future. They exist, but they are permanently disconnected from us. This leads to a profound realization. The universe we can observe is not growing. In terms of accessible information, it is shrinking. As time passes, more galaxies cross the cosmic horizon. Their light becomes increasingly redshifted. Eventually, it fades beyond detectability. From our perspective, those galaxies disappear. They have not been destroyed. They have not vanished. They have simply moved beyond our reach. Billions of years from now, the observable universe will look far emptier than it does today. Distant galaxies will be gone. Only nearby cosmic structures will remain visible. The universe will appear quieter, more isolated. This is not speculation. It is a direct consequence of well-tested cosmological models. Models built on observation, measurement, and decades of evidence. The expansion of the universe was discovered in the 20th century. Later, astronomers realized something even more surprising. The expansion is accelerating. Instead of slowing down under gravity, the universe is stretching faster over time. This acceleration is driven by dark energy, a component of the universe that dominates its large-scale behavior. Dark energy causes space to expand faster as time passes. As it does, the cosmic horizon moves inward. More regions of the universe fall beyond observational access. This means that even if humanity survives for billions of years, even if technology advances far beyond anything we can imagine today, there will always be parts of the universe we can never observe. Not because we failed, but because physics forbids it. This challenges a deeply rooted belief. The idea that knowledge is limited only by effort and intelligence. In cosmology, some limits are fundamental. They cannot be crossed. The observable universe is only a fraction of the total universe, and the fraction we can observe is decreasing with time. Importantly, this does not mean the universe is small. Quite the opposite. It suggests the universe is vast beyond comprehension, possibly infinite. But even if it is finite, its total size far exceeds what we can ever see. The cosmic horizon defines what is knowable through observation. Beyond it, the universe still exists, but it exists without the possibility of direct evidence. This has important consequences for science. Science relies on observation, on measurement, on testable evidence. But there are regions of the universe where evidence will never reach us. In those regions, physical processes continue. Stars form, galaxies collide, cosmic structures evolve, all without leaving any trace that could ever be detected here. This does not weaken science. It clarifies its boundaries. It tells us where knowledge ends and inference begins. Astronomy is not the study of the universe as it is now. It is the study of ancient light, a record of what once was, not what currently is. When we observe distant galaxies, we are seeing them as they were billions of years ago. Their present state is unknown to us. And for many galaxies, their present and future will never be observable. As dark energy continues to drive accelerated expansion, this limitation becomes more severe. The rate at which galaxies move beyond the cosmic horizon increases. Over time, even the most distant visible signals will fade away. Eventually, the cosmic microwave background will also disappear from view. That radiation is one of the strongest pieces of evidence for the early universe. Without it, key aspects of cosmology would be impossible to confirm. Future civilizations may never know that the universe began in a hot, dense state. They may never detect evidence of cosmic expansion. Their picture of the universe will be incomplete. Not because they are less intelligent, but because they exist too late. This reveals an important truth. Knowledge depends on timing. We live during a brief cosmic window, a moment in the history of the universe when large-scale structure is still observable. The universe does not guarantee transparency. It does not promise full access. It simply follows physical law. And those laws impose limits. Beyond the cosmic horizon, the laws of physics continue. They do not break. They do not change. But without observational access, those regions remain unconfirmed. Modern cosmology respects this limit. It clearly separates observation from extrapolation. Models describe what is likely. They do not claim certainty where evidence cannot reach. This discipline is what preserves scientific honesty. Limits are acknowledged, not ignored. The universe is not a single object waiting to be fully explored. It is divided by causality. Different regions are permanently disconnected, not by distance alone, but by the structure of space-time itself. Even if faster travel were possible, the cosmic horizon would remain. It is not a place one can travel to. It is a boundary of information. This reframes humanity's place in the cosmos. We are not explorers of everything. We are observers of a fragment, a meaningful fragment, but a fragment nonetheless. The universe is not arranged for complete comprehension. It is arranged according to physical law, and those laws do not bend for curiosity. Yet even within these limits, the universe is astonishing. The small portion we can observe contains more galaxies than we can meaningfully count. It contains complexity beyond any single lifetime. Understanding that most of the universe is beyond our reach does not diminish science. It gives it context. Science is not about knowing everything. It is about knowing what can be known and recognizing what cannot. We learn not only by discovering answers, but by identifying boundaries. Knowing where knowledge ends is itself a form of understanding. Most of the universe is already beyond our reach, not because we arrived too late, but because reality itself draws a line, and that line cannot be crossed. What we can see is not everything that exists, but it is enough. Enough to reveal a universe far greater than we once imagined. Enough to show us our place, not at the center, but at the edge of what can be known.